Hope in it. In this coordinate, we have to see about message integrity and message authentication, and the cryptography hash function, digital signature, and key management. So, there is only 4 topics, but it is very, very lengthy things. We have to learn each and everything is very clearly. Out of this, today we'll see about what is message authentication. So what is authentication? What is the requirements for these authentications? Why we need to provide an authentication? Then what is the need of integrity? Message integrity, why we need to do the integrity? So all those things we will discuss. Okay, this is the syllabus. If you don't have this syllabus, if anyone don't have that, you can just ping me, I will send you the syllabus. Both in it, this one. So everyone know that what
ఉంది ఇంకొంచెం రైస్ చేయకపోతే
message authentication requirements. So message authentication is there. So why we need to provide authentication? So what is the need of authentication? So can you anyone say that what is the meaning of authentication? Authentication means what? So for example, here we are asking to wear your ID card. What is the need of? So you are going to be wear your ID card. That is authenticate to you. You are from particular section or particular college or particular department. It will use the information about whether you are one or not. So authentication gives the exact things. So for example, if you are failing with any username and password, so please, you are not authenticated to enter it. So who is having a right credentials? Have you heard the word credentials? Right credentials to enter anywhere, whatever it may be. Here we are going to be talking about message. We can generally talk about anywhere we have a right validation we have. Okay. Then the person can able to enter. For that, so what the security? For example, you have your Google PIN or Google Pay. We are going to be use a 6-digit PIN. So that is going to be authenticated by you. So that is the right validation. Okay. So that is the need of authentication. So it is going to be judged that you are the right one to access. So whenever we are going to be talking about network, what is the need of network? So what is the definition of network? Even if in previous classes also we discussed what is the network, what is the network. So one or more systems are communicated. One or more systems are interlinked. One or more systems are connected. So what is the need of connecting one or more systems? So later I will tell you why we are calling again one system is also called as a network. Even if we need a connection, definitely we need a source and destination. In the point of view, we can call the two systems are interlinked, are connected, then we can call the two systems are under network. So even if we can call a single system connecting, single system also can transfer data from one place to another place. Even if we can, for example, actually if we have lab, no network programming lab is the lab, we are going to be communicate one client to another client. Once client server programs are there. So we are going to be open two different command prompts and we are going to be operate. For example, or else we already done any ABMS program. So we are going to be install the server in your system itself, then you can access. Even another simple way which you can understand. For example, you are installing any compiler, then you are going to be writing a program on the compiler. Then compiler is checking your program, your syntax of your program, and this is also communicating one. So actually, we need one computer connecting with internet modem. So virtual memory access will be available in every internet connection, and every data is going to be come from the virtual server. There also we have one computer also being internet. So that is the meaning of connection of computers is known as network. So if the connection is done, what is the purpose of connection? Is there any specific reason to connect? So the reason is to send the data from one place to another place, or one node to another node, or in the interlinked systems. We are going to be sending data from one node to another. If we are going to be send the data, so the data should be reached to the exact validated authenticated person. So what is this person? Exact one, that is the right person to access. I think in the unit one we may come across that triangle shape of security. Have you heard that triangle shape of security? And security is there. In three sides we have data integrity, authentication, three angle, triangle shape. So there. So message should be sending in the network. Definitely we need a right person to access, and the right path to send, and the right destination need to reach. If anyone fails, then definitely the data loss is going to be happening. So why again the data loss will happen? What is going to be happen? Nowadays everything, every even if money also is private digital. If we are going to be lost any miscommunication or misdata to the unknown person, definitely we are going to be lost. Even if we were big data analytics or BWDM, we are going to be talk about data is a very crucial part nowadays. So yeah, so many companies still now they are going to be uh, selling their our own data. Selling data is also sending, that is collecting data and selling the data to the companies also. This is also nowadays a very big business. So simply we can have recommendations how we are going to be do the recommendations to online users. So everything. So how they know? They will know our data. How they know our, what type of products we are selling. So everything. So if data is missing, definitely we are going to be lost something. So if what what type of message authentication requirements? Where are these message authentication is required? So authentication means, so exactly. For example, I am going to be created data for someone, some person. So I need to send the data to exact user. So maybe for example, I need to send 1,000 rupees to my friend. So through digital. So how to authenticate this one? So in where are places, if we simply talk about sending money from one person to another. So not only in a particular case, we have a lot of cases. I define here message authentication requirements. Where are these message authentication is required? So first one is disclosure. What is this disclosure? Releasing of message content to any person or process not processing to the appropriate cryptographic key. So what is a cryptographic key? What is a cryptography? So crypt means something hiding. So why we need to hide? So this is a simple definition from starting of this CNS we may learn. So converting from a plain text to ciphertext to plain text. Here we have two sender to network one process is going to be taken from a network to another receiver is going to be one process is going to be taken. Again, we have a symmetric and asymmetric. A lot of differences are there while we are sending the data in the same key are using or different key are using. Maybe you have a public key or private key. So what are various things are there? Whether these cryptographic key is sharing properly or not. When the sender is releasing a message that is a content is to any person or processing or not, whether it is disclosure or not, in relevance will be authentication. When another one is about traffic analysis, discovery of the pattern of the traffic between the parties. What is this discovery of pattern of parties between this? What is the why we need to discover this one? The name itself is a discovery of the pattern. For example, if I want to know some person, uh, I want to know the some person's address or some person's phone. I don't want to ask him. I need to find address of him, and I need to make some surprise or something I want to do. So what can the things I can do? I need to observe him. Say at what time he is coming, at what time he is going, in which way he is going. Okay. So everything I can observe, then I can do it. So same way here also, when we have a network traffic, so who are going to be hack our data? So the third party person who are going to be hacked, they are observing our data network. So daily at what time he is going to be logging his, for example, if somebody wants to hack our Gmail, so daily at what time he is going to be login your Gmail, at what time he is going to be logged out. For example, he is working, so maybe 9 to 5 is going to be operate his Gmail. Or for example, he is having different time zones. He's going to operate 6 to 9, 7 to 8. So he want to observe everything. So what type of patterns is sending? The patterns is nothing but how he is going to be sending data from one place to another place. So that maybe, for example, I communicating with some other person like this. So what type of communication is going to be happen? We need to observe that. So in such places, definitely this message authentication is required. The connection oriented approach. It may be again it is a big topic, connection oriented and connection less traffic, whether it is TCP or UDP. We may determine any of both of them we can use to send the data. Okay. So either in a connection oriented or connection less oriented, the number and the length of the message between the parties should be determined. So every message we have a particular length. So the length also we can define the IP address itself. So have you remember the header of the IP address? So internet protocol header or IPv4 or IPv6. So message header gives all the information about what is the length of the message, from where to where it is going, and whether it is CRC check is there or not. That is patterns are there or not. Message is properly communicating or not. Everything is going to be reached. Then masquerade. What is this masquerade? Insertion of message into a network from a fraud source. This includes the creation by message by any opponent that is purported to come from the authorized entity. For example, somebody may have doing a fraud. What is that? Maybe, for example, somebody sent, okay, today particular CNN class is going to be uh, conducted by 3:10 to 4:10. By, for example, May, I am giving how daily I am going to be sent a message no? In WhatsApp. I used to start join BDA class or CNS class by this time, this time. So somebody doing the same pattern. So how I am so daily how I am doing the messages same way some other person is done the same thing. Maybe uh, somebody hacked my WhatsApp and they done the same thing. So, but the people who are receiving the message, they may think that the message came from the exact person. So, in such place also we need some message authentication. So, another one is about content modification. So, if the data is sending, for example, if I ask in the starting of the class, I ask you to whether my voice is clear, my voice is audible or not. For example, if you are replying means what I can know that so okay my voice is clear. For example, you are not in a particular link, you may join in the other link. Okay, I'm still teaching in this same link without asking you whether you are audible or not. Okay, so what is going to be happen? I may think that my content is delivered to you. You may think that the content is receiving what I am teaching, the same thing you are receiving. But in between something, some unwanted links or unwanted persons are entered into this conversation and they may diverted. That is the changes of the content of message, including insertion and deletion and transposition and modification. So they are going to be changing of data. Then sequence modification. Any modification of sequence of messages between parties, including same insertion means the sequence may miss. So maybe right message, right sentence is going to be modified into a different form. Then the meaning of the message is going to be different. So that is the sequence is going to be missed. Then timing modification. What is the timing modification? Is a delay or reply of message. In a connection oriented application, an entire session. So in the session where the entire session or sequence of message could be a reply of some previous valid sessions or individual messages in the sequence could be delayed or replied in connection less application an individual message example datagram. So in data link layer we are going to be using datagrams to be delayed or replied. Maybe timing for total we have one word simply when we are going to be log into any banking service that is banking applications maybe online banking online internet banking. So there we have so many uh, session out timings are there. For example, if you are trying to right click on that, or trying to copy, or trying to print, if you are performing these type of operations, it's automatically it is going to be silent. So that is known as a particular session times out. So like that, timing modifications also maybe. Then source repetitions. Journey of transactions of message by the source. So maybe the source, the sender may unable to transmission of data properly. The message is going to be delayed. The destination, same, the denial of receipt the message by the destination. So here we can define the one word simple meaning of acknowledgement. What is the meaning of acknowledgement? So when the source is sending a message to the receiver, then receiver is replying back to the source. Maybe you can call the sender sending a message to the receiver. And when the receiver is receiving message, you need to reply. For example, if I ask, what is your name? Definitely we may reply. So my name is. So then definitely I know that person is receiving my question. So that's when he replied back. For example, I want to know that whether the exact person I am chatting or not. So for that starting, may I know your name? Then you can confirm that. And then if I am going to be do the right person chat, then I can share my data. I can ask any questions to you. So that is when the replies are coming back, that information coming back from the recipient, then this is known as knowledge. So these are the simple message authentication requirements. Where are authentications are needed? These are the places are message authentications are needed. So measure to deal with the first two attacks. So everything we can call as an attack. Attacks are in the area of message confidentiality. So confidentiality, integrity, authentication. These three are the triangles of security. If you remember the unit one. So message confidentiality are the dealt with the part one. Then the measures to deal with the item three through the six. Foregoing the list is generally regarding message authentication. So mechanism for dealing is specifying item 7. So comes under handling, heading the heading of digital signature. Generally, the digital signature technique is also counter some of all these attacks listed under item 3 through 6. So it is a simple meaning of what is a message authentication and digital signature, how to need, which part digital signature is needed. And dealing with the item A, it may requires the combination of digital signature and the protocol design under this item. So if we can conclude these 8 are the attacks. So from 2 and 3 and 6 are foregoing generally for message authentication, and 7 comes under digital signature, and 3 or 6 comes under digital signature technique under counter, and the 8th one is a combination of digital signature and the protocol design counter to these attacks. If you consider all these 8s are in attack, wherever the message authentication is needed, where are the message the digital signature is needed, where the both message digital signature and the protocol design is needed, we can encounter. So if message authentication is a task, then we need to perform this task. We have some message authentication functions are there. That is, any message authentication or digital signature mechanism has a two levels of functionality. At the lower level, there must be some sort of function that produces an authenticator, a value to be used to authenticate message. This lower level function is to use as a primitive and higher level authentication protocol that enables a receiver to verify the authenticity of a message. So these authentication two levels, authentication and digital signature mechanisms are the two levels of functionality. So one thing is going to be deal with whether the right person is accessing, whether the right message is accessing or not. So the one thing is about the right person, the right receiver. Another one is the right message is receiving. So authentication function may be used for the purpose, produce an authenticator, the person here who is going to be authenticate message. These may be grouped into three classes. So one is about message encryption. So what is the meaning called encryption? So some plain text to ciphertext. So the ciphertext of the entire message serves as an authenticator. So who is going to be generate a key? Either may be a public key or a private key. So the encryption technique is going to be done at the sender side. So the person is known as an authenticator. So he is going to be generate a key. Either it informally it may be a formal key or public key or private key. Whatever it is going to be generated, then he is going to be authenticator to the message. Then the particular ciphertext is going to be transferred through the network. whenever the receiver is going to be received, is going to be received along with the keys. Then through that key, he is going to be decrypt the message and we can. So that is message encryption. And another one is this message authentication code, MAC. Message authentication code. So what is that? The function of the message and the secret key is produced fixed length values that serves as an authenticator. What is this fixed size of? So we know that we have various algorithms are there, RSA algorithm. So many algorithms are there. Is a different size of keys are there. For example, you can say RSA algorithm 64-bit key we are going to be used. So IDA we have, again we have MD-HR we have. So various types of these protocols are there to send a message. There we have a different size of keys are there to authenticate. Maybe we can use a 64-bit key, 128-bit key. So what is the size of key we are going to use? That is going to be authenticated by this message authentication. Then another major thing is about hash function. The hash function that maps the message of any length into a fixed length hash values, which serves as authentic. Again, the authenticator is going to be fix that variable length to a fixed size, which we need to serve in the network. Then authenticator is used to fix the size. Then message encryption. So message encryption by itself it can provide measures of the authentication and the analysis of different asymmetric and public key encryption schemes. So we know what is asymmetric and symmetric key. In asymmetric we have same key we are going to use. Sorry, different key we are going to use. In symmetric we have the same key we are going to use. So that is a various schemas. What type of schema we are going to use for encryption. It is also done by message authentication by the authenticators. So we have simple, may feel that this is complicated, but simply we can see that the diagram is simple encryption and decryption only. So source and destination we have A and B. So how we are going to be? So first we can read it. A, what is A? Symmetric encryption, confidentiality and authentication. Confidentiality and authentication. So we are going to be do the encryption with the key and decryption also with the same key. So that is a symmetric encryption. The same key we are going to be using. The second one is our public key encryption confidentiality. So we are going to be use a public key UB something we are going to be used here, and we are going to be do the encryption here. Then so that public key is going to be sent to the another one, to the receiver. The receiver is going to be used the decryption by using some other key. Then another one is about public key encryption, authentication and signature also. So we need, for example, what is the general manner? What is the signature? What is the use of signature? One is going to be get the record signature. What is the record signature? What is the need of signature? What is the use of that one signature? It may be a HOD search or a faculty member is going to be signed in the record. What is the need? So okay, that particular student is done this program. So that is observed by the instructor and he is going to be authenticate that one. So he is that I'm going to be authenticate. That is a signature. The same thing when the message is sending means somebody is the sender is going to be created. Source from the source mission the message is going to be created. There itself we are going to be sending some signature. So it is that okay, it is the exact message. So in digital format only we are going to be do this one, that's only we can find the digital signature. Then the fourth one is about public key encryption, confidentiality, authentication, and the signature also. Along with the signature, we are going to be set. So encryption, we are going to be do. Again, we are going to be check for the digital signature. Then we are going to be send the network. So in between we have KMA, KM, then and this function of E of PUP comma M, then the function of E of PRA comma M. So functions. These are the functions. These are the message authentication functions. Message authentication functions. These are the functions. In one place we are going to be seeing both the confidentiality and authentication. In another one, we are going to be generate a public key and confidentiality. We are going to be in another place we are going to be check the public key encryption, authentication, and signature also. Then another one, public key encryption, confidentiality, authentication, and distance. All those things are so symmetric encryption. Consider the straightforward to use the symmetric encryption. A message M transmitted from the source A to destination B. So I'm giving the explanation about this proposed diagram. So I'm simply reading. Please be listen carefully. Then we can understand. So a message M transmitted from source A to destination B is encrypted by using the secret key K shared by A and B. So the first one key. If no other party knows that key, only sender and receiver only know that key, then the confidentiality is provided. No other party can recover the plain text of the message. So the next one is B is assured that message was generated by A. Why? The message must be come from the A because A is only the other party that process K. And therefore the only other party with the information necessary to construct a ciphertext that can be decrypted with key. If M is recovered, B knows that none of the bits of N have been altered because an opponent does not know. K would not know how to alter the bits in the ciphertext to produce the desired change in the plain text. So we may say that the symmetric encryption provides the authentication as well as confidentiality. First paragraph gives the authentication. Okay, A is a person is going to be create a message, and B is the right person to receive a message. So they both have one key. That key is to open and is to encrypt, and that the key is to decrypt and is receiving the message. Even if the receiver may want to know that whether the encryption is done by the exact sender or not. So the name itself is then the confidentiality. It is the confidence whether he is getting the message from the right person or not. Either any third party person is entered into the network or you may change alter that one. So M have been altered. So he has to know that. So for that only we have included the confidentiality also. So such that okay, the key is there. That is key, exact key I am receiving. That is okay. I have a confidence that the particular key is getting from the sender only. If the sender is sending the same key is using to encrypt, so such that there is no alteration happened in the message. By confidentiality, we can know that the message were not yet altered. So given decryption function D, the secret key K, then the destination will accept any input X and produce the output. So that is the decryption. y equal to decrypt of x is a message and k is the key. So that is y equal to d of x k. If x is the cipher text, why we are calling x is the cipher text? So I said that x is a message. So the message is either maybe plain text or ciphertext. Why it is specifically called it is a ciphertext? Because we are performing the decryption operation. Decryption operation, what is the procedure? The ciphertext needs to convert to the plain text. So what is that message? That X is nothing but a ciphertext. Or legitimate message produced by the corresponding encryption function. Then y is the sum plain message. So once these decryption of ciphertext with key, then we are going to get the original plain text. Otherwise, it likely to be the meaningless sequence of bits. There is need not to be some of automated means of determining at B whether the legitimate a plain text, and therefore we must have come from A. If the incoming ciphertext decrypts the intelligible plain text, if the plain text is says the binary object file digitalized X-rays, determining a properly formed and therefore authenticated plain text, that may be default. So why we are so first one is there we have a key is there to the same key encryption and decryption is going to be happened. But again we need a confidentiality to that whether the exact message is sending the key is shared by the sender is to me only or not any others are received or may change the message or not. In order to know these type of questions also we need to conform with the confidential. So thus an opponent could achieve the central certain level of disruption simply by issuing the message with a random connect purposing to the come from the legitimate user. So what is the meaning of this opponent is? So exact one. So we need to okay, we can confirm that there is a message is confirmed. Purpose. So we have exact meaning to send a right person. So exact person is going to be sending. The exact person is receiving. So that the opponent is going to be confirming. So one solution to this problem is to cause the plain text have a some structure that is easily recognized but that cannot be replicated without force to the encryption function. We could, for example, appending error detection code is also known as a frame check sequences FCS, frame check sequence or checksum. We now have some of the checksums are there, cyclic redundance check. We may know that one, you may have heard that word. To other messages to before encryption. So for example, you can see, to show you the diagram, the source we have. So here we are going to use F, that is a frame detection checksum. We are going to be performed. Then we are going to the message is going to be encrypted before itself. Before encryption itself, it is going to be performing the frame check operation. Then it is going to be encrypted by using a the same key it is going to be performed the decryption. And here we are going to be compare whether the sender message is okay or not. So that is the internal error control and external error. So before going to be see the diagram, I have simple explanation about this internal error control and external error control. What is this internal and external? So a purpose a plain text message and then provides this as input to function f. So the function f that produce an FCS. What is FCS? Frame check sequences. So that is a frame check sequences is appended to the M, then the entire block is encrypted. So before going to be encrypted, here we are going to be check the checksum. So that is a frame FCS. By using FCS, we are going to be calibrate the checksum before it. At the destination decrypt the incoming block and treat it as a result of the message with the appended FCS. So same checksum we are going to be used for the decryption, then with the FCS, with the help of FCS. So B replies the same function F and attempts to reproduce the FCS. If the calibrated FCS is equal to the incoming FCS, then the message is considered authenticated. See that we have various types of plans are there to confirming that whether exact message is sending from the exact sender and it is going to be received by the exact receiver. Up to now, we simply know that the plain text is going to be converted to a ciphertext with a key. The key also there before encryption itself, we are going to be calculate some checksum. That is maybe, for example, so we are going to be sending 10 digits of, sorry, 10 characters. We are sending the data into the network. So for the 10 characters, what is the FCS? For that FCS checksum is what is that? Okay. Then once the checksum is calculated, then if the message is going to be that 10 characters going to be converted into some type of ciphertext. So that is unreadable format it is going to be run. Then the message is transferred in the network. Then we are going to be finalized that receiver is receiving. Then he is done with the decryption. Once the decryption is confirmed, again is to be confirmed whether the checksum is matching with the sender checksum. Then he is confirmed that whether the exact message without any alter, without any modification, without any deletion, the exact message is receiving that. So that is internal. The external error control. So in the second diagram, I will show you. The internal error control authentication is provided because an opponent will have a difficulty to generating the ciphertext when decrypted. When we have a valid error control bit instead of FCS, the outer core, an opponent can construct the message with a valid error control bit. Although the opponent cannot know that the decrypted ciphertext will be. So he or she can still hope to create a confusion and distributed operations. So here we have that an external coding, external control. So here also we have a confusion whether the FCS checksum is correct or not. So in internal, first itself we are going to be calibrate the FCS and we are going to be send the or encryption. But here we have, so for example, the 10 characters checksum is something, maybe the checksum is same for another 10 characters also. Different types of 10 characters also. There we have again confusion. That's why before doing encryption, we done the FCS before in internal. In external, what we are doing? First, we can convert the plain text into ciphertext. Then we are performing FCS on the ciphertext. So that is see that this is a function after encryption. In internal, we have before encryption. So that is a internal and external error. Then we have another important one is about message authentication code. So this is the one of the function we were dealing the message authentication function. We came to know this message authentication code MAC. So defining that in cryptography, a message authentication code MAC is a short pieces of information used to authenticate a message and to provide integrity and authenticity, integrity and authenticity. So that's why the valid person. I used to say that from the starting onward the class. I said that valid. That is authenticity is simply nothing. Valid, exact one. We have a right credential to access one. That is that is a simple one as authenticity is assurance, free from the doubt. You don't have any doubt, so that the exact person is entering into the network or is entering into the message. So authenticity, assurance on the message. So integrity, assurance to detect the accidental and internal message changes. So integrity means combining. So integration. What is the meaning of integration? For example, we have integral 0 to n, or for example 0 to 2 f(x). What is going to be happen? So we are going to be calculated from 0 to 1 or 1 to 2. What is the total? Integration is not the total. Whether the total internal message is exact or not. Is there any accidental defects have happened or not? That is going to be given by the integration. One is authentication is used, we don't have any doubt, so that it's a valid one. And another one we are going to be give about whether we are going to be have any accidental defects are there or not. We need to know that whether it is done or not properly. That is going to be known by the integrity. So authenticity assurance affirms swear. What is a swear? They simply I swear I don't know. I swear I is correct. I swear we are going to be give a promise. That is simple. Authenticity is assurance on the message origin. So origin, this is the message is exact. So we are giving assurance on. Then MAC is also known as cryptographic checksum. MAC will use cryptographic checksum. So how we are done, either maybe internal error code or external error code, we are going to be use some checksum. So what is the message checksum for here? It is an alternative authentication technique involves alternative authentication technique involves the use of secret key to generate the small fixed size blocks of data that is appended to the message. So we are going to be make a small fixed size of block of data added to it is generated and it is going to be added to our personal data. So a MAC cryptographic checksum is generated by the function MAC equal to C of KM, key and message. So M is the input message and C is a C of another. So that is C is a function. Wherever we can simply know C of or F of, we can know that there is a function. C means MAC function. K is shared key of communication parties, either maybe source and destination ARP. Another one is MAC message authentication code. So that is MAC equal to C of K comma. So this is the small fixed block is going to be added to the message. Appended is simple nothing but appended. The meaning is added. Where simple meaning of append, where we can add, where we can add. So we are, I said that we are going to be add, but here we have a adding in the place of appended. What is the meaning of append? What is the difference between add and appended? Add means we can add any place. Appended means it's going to be append at the end of the file. So end always it is going to be added at end only. Okay. When a message to send to B, when A has a message to send to B, then the message plus MAC. So message authentication code is going to be added or transmitted intended, that is aimed to recipient B. Recipient performs the same calculation in the received message using the same secret key to generate a new MAC. The received MAC compared with the calculated MAC. Note, an MAC function is similar to encryption. One, the difference is that MAC algorithm need not to reversible. It must perfect encryption need not to be reversible. So it is not a reversible process. Definitely, we need to. There is we can simply know that MAC is a checksum. The checksum is generated at sender side. The new checksum is generated at receiver side. Then later we are going to be compare the sender and receiver checksum is equal or not. So that is it. I think you can see the third point. Then you can know the meaning of the node. The receiver MAC is compared with the calculated MAC. It is not a reversible. That is the meaning. So MAC function is to many to one. Potentially many messages have some same MAC. That if a message M is 100 bits message and 10 bits is MAC, then we can then there is a 2 power 100 messages and 2 power 10 MACs around. Therefore, 2 power 100 divided by 2 power 10 is equal to 2 power 90 different messages and 5 bit key is used. Then 5 power 2 power 5 equal to 32 different mappings from this set of messages with this set of MAC values. So in general, n bit MAC is used 2 power n possible MACs. So n, how many bits are there? That 2 power n possible MAC are. N is a possible message with n. It is to be 2 greater 2 power n with a k bits key. Then the 2 power k is possible. 2 power k is possible. The simple explanation of MAC. Simple to know that what is MAC means. So we are going to add a checksum to the originated message. So that checksum we are sending to the receiver. It is used to just comparison purpose only. It is not going to be reversible process. So simple how the encryption is going to be taken on plain text to ciphertext and ciphertext to plain text to ciphertext. So here we are sending that MAC. That MAC is not a reversible process. It is a simple process of comparison. The sender is sending MAC. That MAC is going to be checked by the receiver. MAC, that calculated receiver MAC is going to be compared with the sender. So that is the one. Okay, we will continue by tomorrow. Even we have tomorrow in second hour. We'll continue tomorrow. If any doubt, you can ask me now. Or you can